The mission that refused to come home. It was never supposed to last this long. Every calculation said the journey would end years ago. Yet it kept going, drifting farther than anyone planned. To understand why this mission still matters today, we need to return to a time when space exploration followed strict timelines and clear endings. Spacecraft were designed with limited fuel, finite power, and carefully defined lifespans. Missions launched, gathered data, completed objectives, and were eventually shut down. That structure shaped how humanity measured success beyond Earth. But this mission disrupted that logic from the beginning. Built with modest expectations, it was meant to answer a narrow set of questions before quietly fading into history. Engineers never imagined it would outlive its primary goals, much less continue transmitting long after its replacements were launched. Yet with each passing year, it adapted, surviving conditions far harsher than anticipated, refusing to follow the script written for it. As it traveled farther from Earth, communication delays stretched from seconds into minutes, then hours, turning every command into an act of patience. Power levels dropped. Instruments were shut down one by one. Still, the signal persisted, faint but steady, like a heartbeat echoing from the edge of human reach. What made the situation extraordinary was not endurance alone, but relevance. Long after newer missions captured headlines, this aging craft continued sending back data no one else could. It was exploring territory beyond planned boundaries, regions where models grew uncertain and expectations blurred. Slowly, a realization set in. This was no longer just a mission following instructions from Earth. It had become something else entirely, a lone representative of humanity, traveling where no contingency plan existed, rewriting the meaning of an ending in space exploration. As the spacecraft moved farther from Earth, the relationship between humans and the mission began to change in subtle but profound ways, because control gradually gave way to trust. Commands took so long to arrive that real-time intervention became impossible, forcing engineers to think years ahead, anticipating problems that had never occurred before and solutions that could not be tested in advance. Every system on board was pushed beyond its intended limits. Components designed for a few years of operation endured decades of radiation, extreme cold, and constant mechanical stress. Power sources weakened, data rates slowed, and instruments aged, yet the spacecraft continued to function with a quiet resilience that surprised even its creators. With each milestone, the mission crossed boundaries no one had planned for. It passed the orbits of familiar planets and entered regions where solar influence faded and interstellar space began to assert itself. Models became less reliable, and predictions grew more cautious because there was little historical data to lean on. The spacecraft was not just collecting information, it was mapping the unknown in real time. What unsettled researchers was how emotionally attached they had become. Engineers who joined the project as young professionals were now nearing retirement, still listening for a signal from a machine they had helped bring to life. The mission had outlived careers, administrations, and entire generations of technology, creating a bond that felt less mechanical and more personal. As distance increased, so did the stakes. A single error, a minor failure, or an unexpected interaction with the environment could end everything without warning. There would be no rescue, no repair, no second chance. Yet day after day, the signal continued to arrive, delayed but dependable, carrying evidence that the mission was still alive and moving forward. In that persistence, the mission began to challenge a quiet assumption about exploration, that success is defined by reaching a destination and then returning home. This spacecraft was proving that some journeys gain their meaning only when they refuse to end. The true conflict emerged as the spacecraft approached a boundary humanity had only theorized about. a region where the influence of the sun weakens and the interstellar environment begins to dominate. Because crossing it meant venturing beyond the protective bubble that had shaped every mission before. Instruments detected subtle but undeniable changes, shifts in particle density, magnetic behavior, and radiation that signaled entry into a realm no human-made object had ever explored directly. This moment forced difficult decisions on Earth. With limited power remaining, engineers had to choose which instruments would survive and which would be permanently shut down, knowing every choice carried the weight of finality. Turning off a sensor meant accepting that its perspective on the universe would be lost forever. Each decision narrowed the spacecraft's voice, even as its significance grew. As data streamed in, it challenged long-held models of where the solar system truly ends. Boundaries once drawn neatly in textbooks appeared messy, uneven, and dynamic, reshaped by forces far more complex than previously imagined. The spacecraft was not just crossing a line, it was dissolving one, revealing that the edge of our cosmic neighborhood was less a wall and more a shifting frontier. Emotionally, the strain intensified. Teams prepared for the possibility that any transmission could be the last. Every faint signal was analyzed with a mix of excitement and dread, because the mission had become irreplaceable. There was no backup craft following the same path, no parallel experiment waiting to confirm the findings. If the signal stopped, an entire chapter of exploration would close with it. What made the conflict unbearable was its inevitability. The mission could not turn around. It could not slow its journey into the dark. It would continue forward until physics, not planning, decided its fate. In that sense, the spacecraft mirrored humanity itself, driven by curiosity beyond the safety of what is known, accepting that some explorations demand irreversible commitment. The question was no longer how long the mission could last, but whether humanity was prepared for what it might discover before it finally fell silent. The climax arrived quietly, without ceremony, when the data confirmed that the spacecraft had crossed into interstellar space, becoming the first human-made object to leave the sun's influence behind. There was no dramatic visual, no sudden shift in motion, just a steady stream of measurements that revealed a profound truth, that humanity had finally reached beyond its home system, not with astronauts, but with persistence. That achievement carried a strange weight. The mission had not returned, and it never would. Instead, it continued outward, carrying a fragile record of its origin, a silent archive of where it came from and what it had learned. Its refusal to come home became its greatest success, proving that exploration does not always end with arrival, but sometimes with departure. In the years that followed, the mission reshaped how space agencies define ambition. Longevity became as important as speed. Resilience mattered as much as innovation. The spacecraft demonstrated that carefully built systems, guided by patience rather than urgency, could outlast expectations and reach places no bold shortcut ever could. Today, as new missions are planned with grander goals and faster timelines, this quiet traveler remains a reminder that some of humanity's most important achievements unfold slowly, beyond headlines, far from immediate reward. It showed that the universe does not always yield to force or haste, but often to endurance. So what do you think? Are we still measuring success in space the wrong way?